Here we have, I don't know how you pronounce it, Janome DM7200. This icon indicates that the pedal is connected. And we can see this thing up here moving. But when I do this, it will connect or disconnect. It's not always that you may see this problem. It could have been that the copper is off inside, so that you don't see it. So just because you don't see it doesn't mean that it's not a problem. The best way to detect it is by actually moving it and see if the icon changes. Because if you're moving it here and nothing happens, then this is not the problematic end. We will disconnect it before we fix this. So what this pedal does, it's a variable resistor that goes from 0 ohms to 10 kilo ohms. So as soon as you connect it, the machine will know because it's 0 ohms. It's quite easy assembly to open. There is a stop here. So you just need to get this over the other lip there without breaking the plastic. That. Then there is the next stop, maybe. I have never opened these before. Okay, we have the hinge here and here, and it's the same principle. It's just you just need to bend out the flexible plastic carefully, I think. Got a little mark there, unfortunately. We can improve that a little bit. We'll just take a knife and cut off the little out-sticking pieces there. Be more careful next time. But there is, let me see, there is some stuff here. Here is this, like a little ramp here. So when you put this together again, you first insert this end, then you slide it in there. So that's also how you take it apart. This spring is a bit disgusting. We should clear it. And here we can see the mechanism. It's extremely simple. It's a spring-loaded mechanism here that controls a slider. There is a capacitor here for just making sure that the signal is locally stable, I guess. And the reason this happens in the first place is that because when you're done with the sewing machine, you do this. Never do this. This is how you kill cables. Instead, what you do is that you take it like this. And then that's how you have it. You can put a little, like you can take some, like this is for plants, hook and loop kind of material. You can take some of that. This is for like putting plants up on things. Just put it there, and you transport your pedal like this. Because now there are no, I mean, it's kind of sharp. This way it's better, but it's not like this where it's really sharp. And you do this a few times and the copper breaks because you get metal fatigue. So what we need to do here is, so one problem with this cable as is that it's a bit short. It's a fairly thick wire for a signal that is extremely low current, which I find interesting. But that could be to try to remedy this situation. Well, we'll use these for now. So let's have a look here. Yeah, that's quite a lot of copper. So we can make we can splice it here with another cable, and then the new cable we can put in here if we figure out this little thingamajig here. I think this thing is just pushed in like this, maybe we can, because it's like one part here, maybe we can push them together. That worked. Unfortunately, we get some markings up here, but yeah, it's hard to do this completely without making marks. These things are essentially assembly ones. You poor cable. So the purpose of this thing is to protect the cable from being pulled out. But yeah, I don't know. I feel that in this case it may actually cause more damage than good. Now we need to figure out how to get this circuit board out of here. We could lift this out. It has some grease. We'll clean it later. Now maybe we can just slide the board out. No? Ah, it has two little plastic hooks in the bottom there. So let's see if we push one in here. Careful so we don't break it. Actually, I think it's better to bend here, but we'll use something smaller than this screwdriver. And we need to be careful because if you bend these back too much, they snap. Here we have a smaller screwdriver. So we want to line it. Let's see, can I show this? Want it to line up here, but from the back. Now we can bend it back enough that we can pull it up a little bit. Just lost my grip there. Now we've gotten it past the lip, so it will hold there, but if we get it just a little bit down, it will snap back. Let's see if we can get the other one up. If I were to repair like 100 of these, I'd probably just use take some sheet metal and make a tool that could open both of these at the same time, and that would also make sure to not open them too much, to risk damage. Now I think we have come past the lip in both ends, so we can put the screwdriver under here and push it up a little bit by rotating the screwdriver. Now I can use the bigger screwdriver, work it up like this, and now we can pull it out. We'll clean this up a bit too. So here is the circuit. It's extremely simple. This capacitor is just in series with, no, it's that's weird. The capacitor is actually in series with this potentiometer. Interesting also that it's much harder to take it to one, like much more force this way than the other way. But that could just be, yeah, it has some grease in here. We have L and M. No idea what that means. But L is the marked one. So we need to remember this because this capacitor has polarity. So it will probably be fine in reverse. There's probably not a lot of current going through here. But we shouldn't, we should keep the polarity correct. But we will desolder this thing. And L is the marked one. To use some flux to make it easier. And kind of don't want to waste a bunch of solder braid on so much. So let's take some of this. I'm putting it multiple times because each time some of it creeps up here, but then the rest of it is in the way, so we do it several times. And notice that a lot of these are snapped here because I wasn't being very careful, because the purpose here is just to get something to use as to suck up the excess of the solder here. You may not be aware, but copper leads heat pretty well, so it's a good idea to not hold this with your bare fingers. Clean the tip a little bit. Found my side cutters and found my 2 propanol. Thinking clean this up here. Oops, squirting it all over, but it will evaporate quickly. It's quite dirty here. L was marked, right? So, yeah, like that. I'll put it there to remember, or maybe over there. Let's see if we find some cable that we can use here. I think we'll just settle with this lamp cable, because it will add like a meter or so to this. So we'll clean up the end a little bit, like that. Cut away the old crap. Now the question is, do we consider blue or black to be the marked one? I will go with blue as marked one.
Yo, listen.
I'm going to twist them a little bit. Some people say to never do that, but I kind of find it helps to get it in the holes. Okay, that will be good enough. We're going to put some flux on it. I'm going to use the thick lead free. Pretty big pads, gotta put some excess on there. And we can snip the excess here. Gotta be careful because it's easy to create mechanical damage from the forces when you snip it. But this is also a pretty robust thing to begin with, so it's good to know these things, like in case you're working on something that is less robust. Take some of the dust there and the goo there. Take some of the worst off here. I mean, it's good that it has some on it, but it doesn't have to be like completely sticky. Just taking the worst here. Might as well while it's open. So it has a bit of a loop here in the end. So we're going to cut it before that. put this back. Cable relief, I guess. Maybe they're called relief, I don't know. But I think it had this part at the bottom. I just realized that you can actually just put this on from over here. Good thing we can learn things. So if we put it on here, or maybe here, then when we put it in we get some relief there. I'm going to push it more, or to compress it here at the end that goes first in, because that's the biggest issue right now, to get it into the hole at all. Oh yeah, we're getting it in. Ah, dang it. Was close. Oh yeah, got it in. But yeah, this has the same problem as before. If you keep doing this, you will eventually hurt it. I even keep my finger here to be like, you could do it like this if you're careful to put your finger there. But I think in general it's better to take it like this and you loop it like this. Then when you put it in your bag, you don't like bend it over like this. In that case you let out a little bit. And you let it, because then you get like a nice round thing. I guess we can put this thing together now. Oops, blue was marked. Yeah, I'm missing something. This part we're missing. I don't know, it doesn't matter which way it is. I don't think it does, but I think it's better if this part is to the left, where it doesn't intersect with the cable. And I suspect that this pin here is so that the cable goes like that. I guess the problem is a bit when it snaps into place, this thing will fly away. So if we can keep it a bit more together. It looks like it's in place there, good. Probably need to we set it on 20K. Got 0 there. Oops, trying to hold, kind of hard to hold the instrument in here. Also not making them short each other, because then we also get 0. I guess the capacitor makes the change be somewhat slow, and it's probably extra slow when you measure it like this, because this one uses a fairly low current when it measures these things. So that means that the capacitor may charge way faster when it's actually connected to the machine and be more responsive. Now we need to splice this, and preferably making it look somewhat reasonably well made. We'll clean it up a little bit. We'll make them a bit different length, so that the splicing itself is a bit overlapped. And blue was marked, and it's not connected in that end. We don't want to risk damaging the machine. So this means that we need to cut this one up here to compensate. tape is disgusting. Should make some nice nylon, I don't know what you call them, the end of the screw thingamajig, but the end of the vise. Something like that. We want some heat shrink tubing, which I have to find. So this might be like half an hour of recording now. Yes, but don't worry, I'll cut it out. But haha, got a bag of goodies. Think that might work. Going to put some flux on. That fills several rolls. For one, it makes a good contact firmly to start with. Should I put that there and use my left hand? I don't know, I guess that's overkill. Yeah, so it helps with cleaning the surface and stuff for the solder to take and flow. But it also provides a bit of an initial contact, which makes it easier. Now one problem here is that this heat shrink already started to shrink a bit because it was a bit too close, so it got hot. But since this end was thinner, it still works out well. Oops. You could fix this with a lighter or something, or some like bigger heat air. I like to use this thing, and I like to run 150 degrees when I do this. Right. Then the other end. I'm going to actually open it up a little bit. And I also realized something very annoying. I wanted to have an outer thing on this. This is not a heat shrink, this is a silicone sleeve. I wish I had a few more colors in each size. It's not very pretty with red here, but that's the one I have in that size. So we'll put that thing on first. Put it a bit away like that. Sorry that I'm barely showing, but yeah, I'm just putting it on there and take it back a bit. Now I've purposely put the one with the aluminum ones here, so the aluminum is contacting the heat shrink here, because there will be heat going in here, and I want to prevent the heat shrink from prematurely contracting, so I'm hoping that by doing this, that might help a little bit. Flux on there. We'll solder it. let it cool slightly. And we can take the heat shrink tubing. Looking reasonable. And we'll turn it around. Actually, I think it's better to just, I don't know, this one is thinner, it doesn't lead heat as well, so let's turn it around so that we can use the aluminum here for the same trick. Is it a bit too long? Or is it just weird? I think it will be fine, hopefully. This may not be the best, well, I mean, I'm pretty sure that nothing I do is the best way of doing something, but there might be way better ways to do this. But I want to have the tweezers. No, yeah, the tweezers. Can help shape it a little bit. Yeah, we'll do something like that. Some flux on it. I'm getting a poor thermal contact going on. When in doubt, more flux. Actually, I think the tip is just dirty. Something like that. And we'll pull this one ahead. Something like that, perhaps. A nice thing with a temperature controlled heater like this is that you don't really have to worry about heating too much. If it's just like here is 2 kilowatts of thermal heat, then if you have it too long, it will cause problems damage. This would be fine. I just hope that this will survive my mother's treatment of this pedal. But yeah, I'm going to show her how to properly wind it to prevent it from happening again. So let's take out some of this stuff that's in the way here. So, moment of truth. Where do we see it? That. Seems to be working. So remember now, go out a little bit from the thing. Do not bend it close to here. That's very short-lived cable. Find like a nice loop size that you like, and like follow along. Like don't force the cable. Like if it doesn't really want to, then you like turn a little bit. So you try to like imagine that you want the cable to twist as little as possible. Like you want to make it in a really nice loop like this. Then, once we have a loop that we're happy with, just put something like this on or whatever. And then, when you put it down, put it so that you get like a nice bend here, so you don't have a sharp bend. So like this is a good way to store it. And I mean, it could live there, I guess. I don't really know how she usually put it in the bag. But yeah, I'm going to pack it down and it's finished. That didn't sound good. If it sounds like that, you did something wrong. Oops, Daisy. Didn't break it. Come on. Something like that. Ah, dang it. I thought I had it there. This is embarrassing. I'll blame that I'm working in a funny angle because I'm trying to also film it. Let's see, I want it in that angle. So I'm going to keep it oriented like this. So I get this, I don't know what you call them in English. In Swedish is kabeldragavlastning, which means like cable relief, I guess. Maybe they're called relief, I don't know. But I think it had this part at the bottom. I just realized that you can actually just put this on from over here. Good thing we can learn things. It's also a fairly, like, let's have a look here. If I find my... So to finish some of my sentences that I've started, it's a fairly thick wire for a signal that is extremely low current.